This is our introduction to trigonometry. One of the things that you guys were told to use is something called Sohcahtoa. So that is worth memorizing because that tells you here that sine of an angle is equal to opposite over hypotenuse. And I usually abbreviate that as O over H. Then cosine is equal to the adjacent angle over the hypotenuse, or A over H. The tangent is equal to your opposite over your adjacent, over A. So if you look at this angle here, angle theta, and you look across from it, the angle or the side directly across from theta is the opposite one. And then the other leg, or the other angle, that is not what we would call the hypotenuse, would be your adjacent angle here. And then our hypotenuse would be that longest side here. So if you look at number 1, it says find each ratio, and then be sure to reduce if possible. And sometimes they ask you to write this as like decimal to the nearest hundredth. It says to find the tangent of z. Tangent of z, here's your z, would require that you're going to be using opposite over adjacent. So opposite over adjacent. So look at tangent of z. That would be where we could put the theta. And the opposite, the side opposite of it would be 32 over, then you would have the adjacent angle. Remember, it's not your hypotenuse, it's the other one, so your adjacent angle would be here at 24. So that's what the tangent of z is going to equal. So we can reduce that. 8 goes into both of those, so that would be 4/3. Since we're reducing our ratio here, you could also use a calculator to get 1.3 repeating. This one here says to do sine of x. So this would be where we could put our theta, because we're going to be dealing with angle x. And so sine, if again you go to the top here, is opposite over hypotenuse. So opposite of theta is going to be 20 over the hypotenuse here is going to be 25. So we can divide a 5 out of both of those to give me 4/5, or if you changed it to a decimal, it would be 0.8. And we look at number 3, the cosine of A. Cosine of A, go back to your top here, is adjacent over hypotenuse. So adjacent over hypotenuse. So let's find the A, we'll put our theta in it, and we're going to do the adjacent angle. So this one's opposite, which makes this adjacent, 27 over the hypotenuse here, which would be 45. And let's see, 9 would go into both of those, so that would be 3/5 or 0.6. And then sine of C. So again, remember, sine is opposite over hypotenuse. So here's your C, which is where we put the theta. So opposite of that would be 40 over the hypotenuse here would be 41. And that's as much as we can do with this one, so we can go ahead and box this. So then we're given a question like numbers 5 and 6. So we're going to go ahead and know that we've got our right angle here, and because B is in the middle, we'll put that there. So we can have A, B, C. So AB is going to be 8. BC is going to be 15. And AC is 17. And check that. The shortest side should be the shortest unit. The longest side, your hypotenuse, should be the longest unit. So now it says, what is the tangent of C? So this is the angle we're talking about. And remember, tangent would be opposite over adjacent. So tangent of C would be opposite, which is 8, over your adjacent. So opposite over your adjacent, which is 15 here. And because I want to practice changing this to decimal form, which is what your homework will do, then you can go ahead and just divide here, and we'll round it to the nearest hundredth, which will be 0.53. So either one of these answers would represent the ratio given for our tangent. And then we have sine of A. So here's sine of A. Remember, it's going to be opposite over hypotenuse. So sine of A would be opposite 15 over the hypotenuse 17. And again, just to practice getting it in decimal form, that would be roughly, if we round it to the nearest hundredth, would be 0.88. So there is our sine of A. Give me just a second. Okay. So then number 7 here says, what's the length of ABC? All right, so we want to go ahead and fill this in. Here's our right angle. Here is B. We have our A. We'll just go ahead and put A here and C here. And we're told that sine of A is 12 over 20. So here's A. We could put our theta in here. And sine of A would be your opposite. So the opposite value would be 12 over your hypotenuse, which would be 20 here. And then you could use the Pythagorean theorem to figure out what that final side is. So 20 squared minus 12 squared. Take the square root of that answer, and that would give you 16. So here we go. It says, what is the length of AB? So I just used the Pythagorean theorem to find the missing side, so that would be 16 units. What is the tangent of A? Remember, tangent of A would be opposite over adjacent. So the opposite of A would be 12. Over the adjacent would be 16, which we could reduce that to 3/4 or 0.75. And then the cosine of A. Remember, cosine of A is going to be adjacent over hypotenuse. So the adjacent angle, this one's opposite, so that makes this adjacent over the hypotenuse, which would be, 4 can go into both of us, it would be 4/5, or you could say it's 0.8. And then we can do one more. Here we've got hat, and our H is the one that is 90 degrees. So then we can go ahead and just fill in our information in A, T. And so I'm told tangent of T. So here's T. And tangent of T is going to be, remember, tangent is opposite over adjacent. So the opposite number would be 12. Over the adjacent number is 35. So we can actually use the Pythagorean theorem to find our missing side. 37. So AT is 37 when we use the Pythagorean theorem. And then it says, what's sine of A? So now we're dealing with this one right here. Sine of A would be opposite over the hypotenuse. And then what's the cosine of T? So remember, cosine is going to be adjacent. This one's the opposite, so this makes this adjacent over the hypotenuse.